Okay, so the next couple of lessons I'm going to spend talking about factorizing cubic expressions and then how to solve cubic equations. What I want to show you this evening are remainder theorem and factor theorem. Now we need factor theorem in order to be able to solve cubic equations and to factorize cubic expressions if we have not been given a factor. All right, so that's why I just wanted to go through this. Remainder theorem and factor theorem are things that, I mean, look, it can be asked in exams. It doesn't often get asked, but we need to understand how these things work before we move into the stuff that definitely is asked in exams, which is the factorizing and the solving of cubic equations. Okay, so I am going to take this lesson and the next lesson to explain the concept. I just want to run through remainder and factor theorem, as I said, before we actually get into it. Okay, so the way that a remainder theorem works is fairly simple, all right? So this expression f of x, this is our cubic polynomial, okay? So this is the cubic polynomial. And this x minus 2 over here is our linear polynomial. All right, so when they ask us to determine a remainder, it's the same idea as this. If I say to you, what is the remainder when 15 is divided by 2? What would you say to me? Okay, you'd say, well, 15 is not divisible by, well, it is divisible by 2, but there's a remainder. So 7 would go in, so that would leave us 14, and then we worked out the remainder would be equal to 1. So in the same way that you can work out a remainder when one number is divided by another number, you can work out a remainder when a cubic polynomial or any polynomial is divided by a linear polynomial, right? There's a shortcut in order to be able to do this. What we do is we take the linear polynomial and we make it equal to 0 and we solve for x. And then we take that value and we sub it into our cubic polynomial. So in other words, I can calculate my remainder when I sub in 2 in place of x. All right, so I would say 4 times 2 cubed minus 8 times 2 squared plus 2 plus 2. And then I would be able to work out what my remainder is. Okay, so in this case, you guys can work it out. What is my remainder? What are you guys getting as an answer? That's it. Okay, good, well done. So the answer would be 4 in this case. Your remainder is 4. Okay, I'm going to move on. Is everybody happy? Are we thumbs up? Any questions? Easy enough? Cool. Okay, moving on. All right. So what I want to do is this slightly more difficult question with you. All right, so we're going to focus on this one. All right, so we want to find or determine the remainder when f of x equals minus 9x squared minus 3x plus 1 is divided by 3x plus 2. Okay, so remember your first step is to take 3x plus 2 and make it equal to 0. When you solve for x, you'd end up with negative 2 over 3. So your remainder, when you sub negative 2 over 3 in, you'd end up with that. Okay, you guys go ahead and go and work out what the remainder is. Cool. All right, so I'm getting -1 as well. Well done. So it's very easy. Katleho?
Ma'am, my maths teacher made it like a little bit complicated, ma'am. Unless I was not paying attention. So, ma'am, can you please just re-explain? Because like now it looks so easy, but I don't get it.
Okay, so so in other words, all you're doing is you're calculating a remainder. All right. So you take your linear polynomial, you make it equal to 0, and you solve for x. The value that you get for x is what you sub into f of x in place of x, and that's your answer. And that's as difficult as it is, all right? Where it gets a little bit more complicated, Katleho, is where they ask you to now start solving for variables, which is what I'm going to show you. Okay, so I've taken the linear polynomial, I've made it equal to 0, I've solved for x. And then I'm taking that value and I'm subbing it into f of x. And the answer that I get, so in this case, -1, that's my remainder. It really is no more complicated than that. Okay, let's move on. Pinga, that is a very good question. All right, we'll talk about that now. There's a lot that I want to show you this lesson, but we'll talk about it now. Okay. Let's have a look at this particular question. All right. So again, if you want to come back and come and try this, if you want to watch the video again or take a screenshot, same as with the other one, if you want to try another one of these, you're welcome to do this one. So take a screenshot of that. So screenshots. And if you guys want to come back and try this one as well, you can try that one. We're going to do this one here as an example together. All right. Oh, actually, that one is not a nice one to do. Sorry, that's not going to work in this situation because it's a factor. Okay, so I want us to deal with remainders. Okay, let's do this one together. Okay, so they've told us the remainder when f of x is divided by x plus 3 is 15. Determine the value of a. So in other words, they want us to work out what that value over there is going to be. All right, so Katleho, you're going to take that x plus 3 and you're going to make it equal to 0. So x is equal to -3. So your remainder, when you sub in -3 into -2 times 3 cubed plus a times negative, oh, hang on, sorry, I left the negative off there. -3 cubed plus a times -3 minus 4 times -3 plus 3 is 15. Okay, so what am I going to replace with 15? My f of -3.
Ma'am,
Yes, Kamgelo.
sorry, I think you forgot I squared on the a into -3.
Thank you, I did indeed. Sorry, I was writing too quickly, wasn't I? Okay, so let's just make sure I've -2 into -3 cubed plus a into -3 squared minus 4 into -3 plus 3. There we go. Okay, so now we're going to make that equal to 15. So we've got 15 is -2 into -3 cubed plus a into -3 squared minus 4 into -3 plus 3. All right, now what I'd like to do is I'd like to leave you guys, you work out the value of a. I'm going to leave you guys to work out the value of A. And then when you're done, say done in the chats. Excuse me. Cool. So just wait for a couple more people to be done. Well done, Korma and Keith Lynn. And Z. And Serfatso. Chloe and Masike. Okay. All right. So all of those people that have said they're done, what did you get? As your value for A? 6. Okay, cool. Well done. So you would have ended up with 15 equals. This would have given you positive 54 plus 9A plus 12 plus 3. So we would have had 15 minus 54 minus 12 minus 3 is 9A, which would have given us, I'm getting negative 6. So that would have given you negative 54 equals 9A. Divide both sides by 9, and A would be equal to negative 6. There we go. Okay, so negative 6 is indeed the correct answer. Are there any questions? Any questions? Okay, you see you went off a little bit. Okay, Tanda. All right. Okay, in that case, let's move on and let's have a look at another one. All right, so then they can step things up a little bit and they can give you something like this. Okay, so the remainder when g of x is divided by x plus 1 is negative 9, while the remainder is 6 when it is divided by 2x minus 1. Determine the values of a and b. So how do we think that we're going to do this? How do we think we're going to solve for a and b? We have to solve. That's it in Kanyiso. Okay, we have to solve simultaneously. So if we are solving simultaneously, it means we need 2 equations. All right, so can anybody help me set up the first equation? I want to set up the first equation. So in other words, where g of x is divided by x plus 1, the remainder is negative 9. Can anybody help me with that one? What should I write? Don't be shy, Matrix. We'll help you. Yolanda and I will help you. Gets boring listening to my voice and all the time. Cool. Katleho, go for it. Awesome.
Ma'am, aren't we supposed to substitute, ma'am? But first, ma'am, we're supposed to say x plus 1 equals to 0. And then x equals to negative 1. And then, ma'am, we
Lovely.
substitute negative 1 in the equation.
Absolutely. And what you're going to make the equation equal to?
Equals to -9, ma'am.
Beautiful, beautiful. So you're going to say -9 is equal to 16a, and then you're going to sub in that -1 just like you said. Okay, minus 2b times -1 plus 5. And then we can simplify that a little bit. So we're going to end up with -9 is equal to, that would give us -16a. And then this would be plus 2b plus 5. And when I take the 5 over to the other side, it would be -9 minus 5. That would give me -14 is equal to -16a plus 2b. And I'm just going to leave my equation like that for now. Okay. Now we want to make the other equation. Okay, so Kamogelo got a is 1. Okay, Kamogelo, you are on fire. All right, so making the other equation matrix, what am I going to write? Anybody want to give us a suggestion? What am I going to make it equal to? So what am I going to make g of x equal to? So when I sub in 1 over 2, I'm going to make it equal to 6. Good, Keithlin. Perfect. Good job. Okay, so 6 would be equal to 16a when I sub in 1 over 2. Nice. There you go. All right, so that's going to give us 6 is equal to 2a minus b plus 5. And then I'm going to take the 5 over to the other side. So I get 1 is equal to 2a minus b. And that would be my second equation. That's it, Nizuli. Okay, so g of a half would be equal to 6. Lovely. Okay, now I need to solve simultaneously. So probably the easiest thing for you to do is make b the subject of the formula by taking it over to the other side and bringing the 1 back this way. And now we can take this and we can go and sub it back into that other equation over there. So we'd end up with -14 is equal to -16a plus 2 times b, which is 2a minus 1. And then removing our brackets, we'd end up with 4a minus 2. So on this side over here, we've got -12a. On this side over here, we've got -12. So you're quite right, Kamogelo, a is equal to 1. Good job. Okay, now when we go back and we solve for b, we'd say 2 times 1 minus 1, which would give us b is equal to 1. Okay, so a is 1 and b is 1 in this case. Are we all good with that? Any questions? Cool beans. So thumbs ups. Moving along. Good. Well done, everybody. Okay. So now let's talk about factor theorem. Okay. So if a number is a factor of another number, so if I take the number 14 and I divide it by the number 2, all right, what is my remainder going to be equal to in this case? Exactly. All right. My remainder is going to be 0. So if a linear polynomial is a factor of a cubic polynomial, the remainder is going to be equal to 0. Okay, so when they ask us to show that x plus 2 is a factor of f of x, we want to sub -2 into f of x in place of x, and we're expecting to get 0 as an answer. Okay, does that make sense to everybody? Okay, Kamogelo,
Hi, ma'am.
Hi.
Hi. Could you please repeat the last statement you said? I just kind of didn't get it.
No, that's fine. That's not a problem. Okay, so when we're talking about remainder theorem, if we take a number or a cubic polynomial and we divide it by a linear polynomial, we get a remainder that isn't 0 because the linear polynomial is not a factor of the cubic polynomial. In this situation over here, x plus 2 is a factor of f of x. So because it is a factor of f of x, we get 0 as our remainder. In the same way, 2 is a factor of 14. So when I divide 14 by 2, I get a remainder of 0. That's what I was trying to say.
Thank you.
Okay, no problem. So you've got two situations that can happen. When your cubic polynomial, or any polynomial, doesn't necessarily need to be a cubic, it could be a quadratic polynomial. When a polynomial is divided by a linear polynomial, you can either get a remainder that's 0 or that isn't 0. If it isn't 0, then the linear polynomial is not a factor. If it is 0, then the linear polynomial is a factor. Does that make sense? Thumbs up, thumbs down. Are we all okay with what I'm... Cool. All right, so Keith Lynn, Eve, P, Wayne, Lady. Cool. All right. So our remainder is 0 in this case. Okay. Well, that's what we're expecting to get. Okay, so now we're going to sub in -2. Okay, and look at what happens. We're going to sub -2 in here. And we end up with -8 plus 6 plus 2, and see, we do get 0 as an answer. Okay, and then we must conclude, therefore, x plus 2 is a factor of f of x. Okay, so because x plus 2 was a factor, our remainder is 0. All right, so now we're going to move on to the next thing. Screenshots. Okay. So if x plus 2 is a factor of f of x, determine the value of p. What do you think we should do here, Matrix? What should I write? Cindy, go for it. Cindy?
Ma'am,
Hello.
you should make x equal to -2. Then you
Lovely.
substitute the equation.
Exactly. And then what are you going to make f of -2 equal to?
F of -2.
So in other words, this bit on the left-hand side, what's this going to be equal to? That's my remainder. What's my remainder going to be in this case?
8.
Because x plus 2 is a factor, so my remainder is
0.
0. That's it. Good. Well done, everybody on the chat. Okay, so that's going to be equal to 0. So let's just go and sub in the -2, as you said. And then we can bring all of this down. So that would give us -24. And that would be 4p plus 4 plus 8. Okay, good. Well done, everybody. Okay, so if x plus 2 is a factor of f of x, our remainder is 0. Good job. All right, so I'm going to bring the p term over to the left, leave the numbers on the right, and that means that -4p would be equal to, oh, not 18. would be equal to -12. And then I divide both sides by -4. So we should be getting that P is 3. Yes, and Kaniso, good job. Well done. And then again, they can expect us to do something like this simultaneously. All right, now what I wanted to do is that, sorry guys, let me just grab that. So if you want to come back and try any of these questions again, there's one that you could try. All right, so if you want to take a screenshot, guys. If you want a bit of extra practice with that, you can try if x minus 2 is a factor of, and what they really should do here, the textbook's a bit naughty, is that they should have, you know, f of x equals. Okay. Kamogelo, do you want to ask a question?
Ma'am,
Mm.
how is it marked and how many marks does it normally carry?
Okay, so something like this, there would have to be a mark for making it equal to 0, because then you understand that it's a factor. There has to be a mark for subbing in, and then there would be a mark for your answer. Okay.
Hello, ma'am.
Hello, Tsegofatso.
Yeah, so the difference between remainder and the factor is that the factor you make it equal to 0, and the other one you don't equal it to 0.
Exactly. Because the idea is that, and again, just think about numbers. If you're confused when it comes to letters, think about it with numbers. All right. So if you take a number like 17 and you divide it by 3, your remainder isn't going to be 0, is it?
Yes.
Exactly. Okay. So if you take a number like 16 and you divide it by 8, your remainder is going to be a 0. Okay. That's because 3 is not a factor of 17, but 8 is a factor of 16. So when you get a remainder, either it's 0 or it isn't 0. If it is, okay, that's your two options. Okay. Either it's 0 or it isn't 0. If it isn't 0, then your factor, your linear polynomial is not a factor of your cubic polynomial. If you do get 0 as an answer, then it is going to be a factor. Okay. All
Thank you,
right. No problem. Then what they do is a question like this. They kind of combine the two together. And you've got to be careful here when you read a question like this one. It says, given the expression 2x cubed plus ax squared plus b is divisible by x plus 1. Now, if they are saying that it is divisible by x plus 1, what does that mean? If they say that something is divisible by x plus 1, what does that mean? And let's just call this g of x. Exactly, in Kaniso, it means that x plus 1 is a factor. Okay, good, well done. So therefore, x plus 1 is a factor of g of x. The second piece of information is that there is a remainder of 16 when it is divided by x minus 3. Okay, so is x minus 3 a factor? Correct, Nolutando. Okay, so x minus 3 is not a factor. Okay, because the remainder is equal to 16. Okay, so now again, they expect us to make two equations, all right, because we need to solve simultaneously for A and B. What I'm going to try and do is give you guys an opportunity to try this on your own. Okay, and let's see what you come up with, right? Rather than me doing it for you. We will go through the answer again, but let's see what you come up with. Okay, and when you're done, you can say done in the chat. Sure. Good job, Nkaniso. And Nkaniso, if you want to, you can try that one as well. Okay, there's a few of you that are done already. If you want to try another one. Cool, well done, everybody. Good, Hillary, well done. Okay, so if you are finished already, you can have a look at that one as well. And then I'm going to go through how we work out A and B.
Ma'am,
Hi, Hillary.
I have a question, ma'am.
Of course, go for it. Hilary, what's your question?
During exams, ma'am, for differentiation, will they ask us to limit anything?
No, limits are not part of the CAP syllabus. So the only time that you would be using any form of limit would be in first principles. Okay, where your limit is as h tends to 0. That's the only other time. But you're not going to be calculating any other limits. Okay. All right. So there's quite a lot of us that are done already. What are we getting as answers here? What did we get as A? What did you get A equal to? Katleho?
Ma'am, can you equate the two what's this problems, ma'am? Ma'am, I get
When you say can you equate the two problems, what do you mean exactly?
ma'am, first you're going to substitute, right? And then
Yes.
solve the problem, and then
Yeah.
you're going to like maybe make the what's this be the subject of both formulas, ma'am.
Yes.
And
Yes.
then you say,
Yes,
okay, ma'am.
absolutely. Nothing wrong with that. Nothing wrong with that at all. Okay. Well done, Matrix. Okay, nothing wrong with solving that way as well. The other thing that you can do is you can also solve by elimination if you want to. So that's a method I quite like. I often use that. There we go, Sano, perfect. Okay, so A is -5 and B is 7. Good job. All right. Is there anybody that didn't get -5 and 7? Shame, I suppose, Katleho?
It's me, ma'am. I did not get -5 and 7, ma'am.
Okay, that's fine. All right. So everybody else that got the correct answer, you can finish off working out what P and Q are. Katleho and anybody else, let's do this one together. Okay, so Katleho, when you sub g of -1 into g of x, so you're going to sub 2 -1 cubed plus a times -1 squared plus b. Because it's divisible by x plus 1, it means that x plus 1 is a factor, so you would make this equal to 0. So here you should have ended up with -2 plus a plus b. Taking the 2 over to the other side, you've got 2 equals a plus b, and that's your first equation. Then there's a remainder of 16 when we sub in 3. Okay, so when we sub in g of 3, we get 2 times 3 cubed plus a times 3 squared plus b. We'd get a remainder of 16, so this would be 16. Okay, so 3 cubed is 27 times 2 is 54 plus 9a plus b, and then if we took the 54 over to the other side, we'd end up with -38 is equal to 9a plus b, and that would be your second equation. Now, Katleho, you said, can you make b the subject of both and then equate them together? Absolutely, you can. So for equation number 1, b would be equal to 2 minus a, because you've taken the a over to the other side. Here, b would be equal to -38 minus 9a. You can then equate those two expressions. So if you've got 2 minus a equals -38 minus 9a, collecting your a terms on the left, you'd have that. Collecting your numbers on the right, you'd have this. So you would have 8a equals -40, and that's why a is equal to -5. Okay, and then you could use either one of these two equations to then work out what b is. Probably easier to use this one. So b would be equal to 2 minus -5, which is where the 7 comes from. Okay, Katlego?
Okay, ma'am. Thank you, ma'am.
No problem. Okay, so then we were having a look at this particular problem over here. Anyone get values for Q and R? Anyone get values for Q and R? Are we still busy? Still busy. Okay. All right. No
Nice,
problem. Okay.
guys.
All right. Well done, guys.
Well done. You're getting there. You're getting there. Ma'am,
Mm,
could you please go up a bit?
like that,
Yes.
but more.
No, it's fine. Thank you.
Is that enough? Okay. All right. No problem. Zwanaka?
Evening, ma'am.
Good evening, Zwanaka. How are you?
Evening, ma'am. Well, thank you, ma'am. Sorry, I
That's
missed
good.
the explanation of I missed how the explanation of factors got joined in late due to load shedding.
Okay. All right. So what we've been speaking, if you go back and watch this video again, it's going to be helpful to you. It's going to be a little bit difficult for you to understand where we are right now. But the idea is this. It's going to be a little bit difficult for me to explain to you where we are right now. But the idea is this.
We divide.
Okay, so in the example that's on the board, all right, we would refer to x plus 1 as our linear polynomial. Okay, g of x, this is our cubic polynomial. So the easiest way for us to understand a linear polynomial dividing into a cubic polynomial is to use numbers, okay? So if I take a number like 25, if I divide 25 by 5, what is my remainder going to be, Zwanaka?
25 divided by 5 equals 5.
Yes, but what's my remainder?
Nothing.
Exactly, my remainder is 0. But if I take a number like 36 and I divide it by 5 as well, is my remainder going to be equal to 0?
No, ma'am.
No, it
Yes.
isn't.
No, ma'am.
No,
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 ma'am.
it's not. My remainder is not going to be 0 because 5 is not a factor of 36. So it works exactly the same thing with algebraic expressions. When a linear polynomial is a factor of a quadratic or a cubic polynomial, the remainder is 0. When a linear polynomial is not a factor of a quadratic or a cubic polynomial, the remainder is not 0. Okay, so that's the basis of our discussion this evening. Okay.
Good evening, ma'am.
All right. So, but go back and watch this, and then it'll make a little bit more sense to you. Okay. So, Ikoma got Q is 1 and R is -4. How did everybody? What did everybody else get? Sihawu, Nolutando, did you get the same answers? Did you also get Q is 1 and R is -4? Yes. Okay, that is correct. Okay. All right, well done. Anybody that didn't get that? Okay, so I'm going to leave that as well as something that you guys can try. So Q is 1 and R is -4. You've got that. Okay, all right. I obviously didn't expect everybody to be able to do it. But again, if you want to come back and come and watch the video again and try this again for yourself, or take a screenshot and try it when class is over, maybe that's easier for you. So take a screenshot of it now, at least you've got the answers, you're solving simultaneously. All right, and then just to help you if you are stuck here, so when f of x is divided by 2x minus 1, here, when it's remaindered by this, that's what they mean when they say respectively. That's when the remainder is -1. When it's divided by x plus 2, that's when the remainder is 9. Okay, if you need a little bit of help forming those equations. Okay, so the reason that I have been speaking about remainder theorem and factor theorem is because you need factor theorem in order to be able to factorize cubic expressions when you do not have a linear polynomial. Now, we're running out of time a little bit this lesson, but don't stress. I'm going to spend the whole of the next lesson discussing the factorization of cubic expressions, all right? What I'd like to just get into now, all right, is where do cubic expressions come from? All right, so a cubic expression is created when you multiply a linear polynomial with a trinomial. Okay, it doesn't matter that it doesn't factorize. Okay, we'll worry about that next time. Okay, so in other words, you end up saying you do this. You're going to say x times x squared is x cubed. X times 5x gives us 5x squared. X times 3 is 3x. Okay, then you would multiply the 2 with the x squared. So that would give you 2x squared. Then you'd multiply the 2 with the 5x, and that would give you 10x. And then you'd multiply the 2 with the 3, and that would give you 6. So you'd end up with a cubic polynomial. So in this case, x cubed plus 7x squared plus 13x plus 6. So when we factorize cubic polynomials, we're starting over here. And I am teaching you to go back the other way and put the brackets in. Okay, that's what we're doing when we factorize cubic polynomials. Now, the problem with f of x that's on the board at the moment is we do not know what this linear polynomial is. All right, so the only way that we can do this is to use a little bit of trial and error. What do you think you guys need to do? How are we going to find this linear polynomial based on the discussions that we've had this evening about factor theorem, etc., etc.? Yeah. So it needs to be equal to 0, exactly. So what are you going to make equal to? How are you going to find something that equals 0? What are you going to do? I don't know if it's Shania, or I'm not sure if I'm pronouncing your name correctly. What would we need to do here, do you think? We need to find the factor. There we go. Nolatundo, good. Well done. Kamachelo, I think you had your hand up.
No, Mom, I was gonna say the answer.
Okay. We need to find the factor. Okay, so in other words, you are going to sub numbers into f of x in place of x, looking for 0 as an answer. Okay, that's what you're going to do. Okay, so Bayanda says factor is -2. So Bayanda, are you saying that when you sub in -2, you end up with 0 as an answer? Is that what you're saying? Okay, let's just double check. So if we sub in -2, let's just check. So that gives us -8. That gives us +8. This gives us -2. This gives us +6. Okay, I'm not getting 0 as an answer here. Okay, here we're getting 4 as an answer. Right, I think maybe what you meant by under is the other way around. You can use synthetic. Okay, so either you can use synthetic division, or you can use long division, which is horrible, or you can use inspection. Okay, now the problem with synthetic division is that it doesn't always work. Okay, that's why this method, inspection, is actually the best method, because it will always work in every single situation. All right, so by under, if you sub in 2, then do you get 0 as an answer? Let's just check. So here we've got 8 minus 8. Oh, sorry, I forgot to square this, didn't I? That'll do it for you. So that's 8 minus 16 plus 2 plus 6. Do we get 0 as an answer now? Oopsie. 2, 3. Absolutely, there's a number of different factors. Okay, so there's a few things that are going to work. All right, so here we would get 0 as an answer. So that means that x minus 2 is a factor. Okay, so now when you say 3 is a factor, you've got to be careful. Does that mean f of 3 equals 0? Is that what you're saying? Because then x minus 3 is a factor. Okay, there's actually one more factor in this case as well. All right, and that would end up being it's x plus 1 is also a factor. All right, now, unfortunately, we have run out of time this evening. I'm going to explain to you next time how to use the synthetic division method, but I just wanted to go through this with you so that you know that this is what's coming. All right, so we'll talk about factorizing cubic polynomials next time using inspection. And then we can go ahead and go and solve cubic equations, and I'll explain to you what it means when you are doing that. Okay. All right, Matrixel, if we don't see you on Saturday at boot camp, we'll see you again next Tuesday. I hope everybody has a lovely evening.
Nice.
I think
And I'm also
x
saying
minus 3 is a factor.
x minus
Because
3.
if you sub 3, I'm sure it was.
Yeah, we written it down there. So if you sub in a 3, you get a 0. Apparently, according to how we...
4 times 3, let's just check that, squared plus, it would be 3 plus 6 equals, no, you do get 0. X minus 3 is a factor. You are quite right.
Yes, please do the... Well, please do the quiz. We are done now. We're wrapping up and we are done.
Yeah, just try. Okay.
Let's try on the quiz. Bye, Teacher Lee, and thank you, everybody.
Okay. Bye,
Yes.
everyone.